Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and this is a very important video. So the title of it is Multiplying EM negative energy with series impedances in line propagation with the Ford dual-pole motor. So what we're going to be talking about is the real purpose of these motors, which is really not what people are focused on at all, and haven't been for the most part. But ever since the beginning I've been focused on that, and I will talk about that today. So hang in there, there are some very important points here. We're going to explain how we can multiply the energy out, and we will be doing that as a focus this year and providing actual products that you can add to these motor systems to do that. So let's go over the idea of how this works, and then we'll do a basic demonstration. And I'm just going to do at the 12 volt level here, the input level. So what we have is an article or an email from Tom Bearden, and Tom talks about this. So my dealing with Tom Bearden goes back to around 2004, I believe, where I first met him in his home, and I've got quite a bit of correspondence between me and him over the years. Nothing recent, because he's kind of he's not doing this anymore. He's too old. Anyway, let's see where we begin. So my dealing with Tom is that I went to his home, and I'd already corresponded with him, and I thought, hey, better go and visit him while I can, while he's still alive, and so I asked him a lot of questions, and one of the things at the end, or some point in the conversation, I was like, well, what is the heart of the matter here? What are we talking about? I'm not a physicist, so he tended to be way above the average person, didn't really communicate effectively to the average person because he was a physicist. And for me, I was just the opposite, your average Joe type of guy, and hobbyist. So I asked him, what is it? What's the bottom line? And I said this before, so today I'm going to focus on it a lot more. What did he say? And we'll read an extension of what he says, but he said series impedances. And of course it was in a context that I want to talk about today. So what does it mean to have series impedances? Now, I didn't understand exactly at the time the difference between positive and negative energy and all that. So, and I think most people don't really. They may use the terms, but they don't really have experiential knowledge of it. So, of course, that made me very curious, and I asked him practically, if we would have to change the grid system if we utilize this energy. He said, no, actually you can utilize it, and we can utilize the whole infrastructure as it is. So, what is it? So we are used to positive energy, current flow. I'm not going to get into trying to define all that, because I'm not qualified to do that, for one, and secondly, I don't want to detract from, I don't want people getting hung up on words. But essentially we're going to make a distinction between positive and negative energy, in which positive energy is what you're used to, in which has all the characteristics that you're used to, such as losses in the line in which you are running a load with a circuit, say a light bulb, across a battery, and you're going to experience heating up of the wire of the bulb, and you're going to have lost energy in the process. Really, it's lost in the battery, but there's radiation in the form of heat coming out of it. So that's the really basic difference that people are familiar with. And so they think that's it. That's all there can be. And so we have this heat death and this whole law of entropy and so forth. So now, on the opposite side, we have what people call negative energy or cold energy. So it's cold rather than hot. And there's these various characteristics that are totally opposite. So on the one hand, we have the positive energy, which represents gravity fields and so forth, or relates to. And then we've got the negative, which actually is going to be anti-gravity. Now, I'm not going to promote anti-gravity experimentation. It's a very taboo subject in which if you start experimenting, you might find yourself in a lot of trouble. So I stay away from all that, and I would never share with anybody any kind of experience I might or might not have along those lines. I have no interest in really having any gravity myself. I don't need it. It would be very interesting, but I can imagine the reasons why certain entities would suppress that experience or having the ability to do that. So we're going to talk a little bit about that in the sense of just mentioning it in this correspondence. So this goes back to 2005, January. So I'd already visited Tom on that way. And actually, jumping ahead here, there's an email that he sent to me on April 2nd, 2008. It's a private correspondence where he said, frankly, the work you and John and Gary are doing is the most important thing going on right now on this planet. And it relates to what he's talking about here in this late or earlier correspondence of negative energy. So we're looking at January 3rd, 2005. And he's replying to this guy named Boyd. And I'm not going to read it all, I'm just going to read some highlights here. And I want people to focus in on the negative energy series impedances. So he says the main key to anti-gravity is the use of negative energy, including negative mass energy, rather than positive energy and positive mass energy. The second key is in the accounting and the use of long accounted but present stupendous heaviside curled energy flow when it is composed of negative energy. So now that's a key. So we've been looking at the heaviside flow, but we want to look at the negative energy heaviside flow. Now that's opposite. So I've done demonstrations at times where we've done the positive heaviside flow, but there's negative. And so we'll talk about that in a minute. In thermodynamics, one of the areas already known to recognize and recognized to violate the second law of thermodynamics is a sudden sharp gradient in the energy density across a little region of space-time. And he quotes books and all that. You can look at this article or this correspondence online, and I'll put a link up in the in the description of the video. So the law of thermodynamics are violated. Woo. So in other words, they're known to be doing just the opposite of what you'd expect. But that's, because everything's backwards. Or opposite, at least. So I'm not going to get into some big debate with anybody about the laws of thermodynamics. It's just really what is an open and closed system. My theory of physics is very open, and probably always will have many questions, things that I'm not certain about. And that's fine, we don't need to know those things to live our regular lives. Anyway, I wanted to just quote that, even though some people will be all upset and huff puff about it. But we can demonstrate what he's talking about. So excess positive energy density of space produces one direction of space-time curvature and positive gravity, attraction. Therefore, negative energy density of space produces the opposite direction of space-time curvature and negative gravity, anti-gravity, or repulsion. So in the 1980s and on into the early 90s, he says, I worked for some years with Floyd Sweet, the inventor of the vacuum triode amplifier, the VTA. Because of the sharp gradient, if one increases the COP to, say, double, then one should materially increase the negative energy and anti-gravity effect, and one should therefore experimentally detect it. Further, since the Floyd Sweet device, the Sweet device, used magnetic fields, and the magnetic field is curled magnetic vector potential, then one is using swirling energy, which may indeed interact with swirling curl huge heavy-side energy flow component. I'm not going to get into all the details, I'm jumping around here. So he said, I convinced Sweet to sow the experiment, must be a typo, to do the experiment by doubling the output. By doubling the output impedance in series steps, that is easy to do because of negative energy flow. Every impedance in series along the let me read this again. I convinced Sweet to do the experiment by doubling the output, and then in brackets he says, by doubling the output impedance in series steps, that is easy to do with negative energy flow. Every impedance in series along the flow freely converges additional EM negative energy flow from the vacuum into the line of flow propagation without work. It's a sort of negative impedance effect, but only for negative energy flow, series impedances in line propagation, which is really my title, and which is what we want to focus on here. So, first of all, he says, I'm going to jump around a bit, by using sharp pulses for sharp energy gradients across very small space intervals, temporarily persisting Dirac-C holes can be produced. They flow backwards in circuits and produce, from the moment of formation, negative energy EM fields and potentials. So we've talked about this, which Tesla talked about, the impedance phenomena, and on the negative side, when we have very sharp gradients, um, like here, which I'm using the gate driver of my motors now. For some people that had the older motors, they didn't have the gate drivers, so we had much less effect of what I'm talking about. So literally a $2 device added creates a much sharper gradient on the MOSFET turn on and turn off. So with those sharp gradients, now you can really create this effect, this negative energy. So you have the forward flowing current, but when you have this abrupt switch, you also have the back flowing negative. And I'm not going to try and say all the characteristics about it, but this is what we're using to charge a battery. And what we'll see here is, in series with the battery, we're going to put this transformer, and then we're going to power this capacitor here and these 400 watt LEDs. And then, so what happens is, this sharp pulse creates this effect, and it's negative resistance happening through this impedance. So here is an inductor, transformer. I'm only using one of the wires, these other wires are not being used. So just a secondary, so it's a very short impedance. And Tesla talked about this 100 years ago, a little bit in the True Wireless and other places. So this is in my resonance book, the whole article. And this little image up here is quite important, and it's, even bringing it to the camera won't do justice to it, it's so small. But he's got illustrating typical arrangements for collecting energy in a system of transmission through a single wire. And one of them is from, so here's the example of one wire, stout copper bars like he used in the Tesla hairpin circuit, which is what I call the Tesla impedance circuit, and where he actually ran light bulbs across 2 points. If you had this bent around, it doesn't have to be, but if you had the frequency high enough, you could power, 100 watt bulbs or what have you between 2 points on a single wire transmission. So it's shorted, and yet it's still powering. So he shows these examples of running power across a distance parallel to it, embedded in the wire as well. So there's five different ways that he shows that. But I don't know if he ever really articulated the idea of the negative energy in such a way as we understand it now, in his own words perhaps. But so what happens here normally without this additive, which is just, like I said, in series here with the charging battery, and it comes back around. So this is a charging battery. And so what happens is, the battery itself is such a negative impedance in each one of its cells. So we have 6 cells in here, and so the negative energy component that is coming from the sharp gradient pulses is making its way through this red wire and then coming back around. So I really have the wires all in the wrong directions, but the point is as it's passing through each impedance, it's not only becoming a negative resistance in each one of those cells, each one of those cells is being charged with massless current negative energy. And so what's happening is not only that is taking place, but also what's happening is the heavy side flow, which is at right angle, is being collected like a sail in the wind, collecting this energy in the plates. So as I've said for years, and few people have ever bothered to pay attention to this point, but I'll keep hammering it, and there's deathly silence on this throughout the whole entire internet. But the bigger the plates that you put, like the bigger the sail you put up on your sailboat, the more you're going to collect, the more charging are going to take place. So a bigger battery, bigger capacity is going to collect more of the heavy side current, and more impedances. When you have a good battery, good clean battery, rejuvenated, brand new, whatever, either way, then you can add many cells in series, so you can have higher voltage battery. So this still has a little bit of positive energy kind of mixed in with it, so it's not quite the purest of pure processes, but we want the battery to not become like fully negatively charged, so we limit that in this case. But if you wanted to do the pure process, then you could do the older circuit that we've done, and then you just dedicate those batteries to be negatively charged, and they will have very interesting characteristics about them. But you cannot run them on the front end of the motor and rotate the batteries in that case. And that's what I focused on over the years, is trying to rotate the batteries for people, because that's what they wanted. Nobody wanted to do the big battery banks. Like I've gotten up to 200+%, or 200 times, sorry, more charging output than input when I've had really big battery banks. So 48 volts of 2000 volt batteries. I was running a motor, the little 3-pole monopole that I used to make and sell. I was running that at 2 amps, 12 volts, and I was charging up those big batteries, over 200 times more output than input into those batteries, because they were big, huge, low impedance, or they were really big impedances, back to back, and so they were collectors of energy and negative resistors. So as we increase that size, that's a phenomena that's opposite to the positive current. If we charge batteries like that with 2 amps, 12 volts, first of all, the potential is lower, so we couldn't charge those batteries with 12 volts. And if we had a 48 volt input, well, we'd have to have higher than 48 to actually charge a 48 volt battery, but if we were charging those batteries with 2 amps, then we wouldn't really do anything to them. It would be very... but when we actually look at the amperage going into the charging battery, we find that there is no amperage in that case that I was running it. So then you really scratch your head and say, well, how is it that there's no amperage and this battery's charging? Because everything is the opposite. It's negative energy. Now it's widely admitted that negative energy is the back EMF, or the reverse flow, the collapsing current in the coil and whatever, but it's actually not only the collapsing field, but it's the switch on of the coil. It's the changing magnetic field that's going to give you this response in either a secondary of a transformer, or in this case charging of a battery. The discharging of the coil is the turn off, but the level of intensity of it is based upon the rate of change. So that means the sharp gradient. The sharper the gradient, the greater the rate of change. therefore the greater the output in this energy. So, the higher the spike you'll see. So what I have here in this case is a transistor that is 900 volts, and what I've done is put a much smaller capacitor across it. I'm not finished with doing all this, but I thought I'd do a video at this point. And what I have here is 0.1 microfarad across the gate, or the drain and the source, I should say, of the MOSFET, because I still need to make sure it's lower when I do this process and when I do other processes and when I go up to higher voltages. We'll see here that I brought it down quite a bit, and I think what I'll do is cut that while we're running it and see the difference. Or probably just disconnect it. Yeah, I'll just unscrew it and we'll stop it and start it again. Anyway, the other thing that I have, the problem is that if I add too much capacitance there, and I've added that capacitance over the last year because we were exceeding this MOSFET's 100 volt maximum very quickly, especially when we do this effect. So we're going to talk about all that in a minute, but so let me not go into that quite yet. Let me finish what we're talking about here. But we were doing that, and I think I decided to up the voltage of the MOSFET so that we could go to higher voltages across the MOSFET without adding too much capacitance. Therefore, the more capacitance we add there, the less battery charging we have, the less of this negative effect. So, negative energy effect. So what I'm saying is that we're making a big change here, and I will be, I'm saying this for all the people who have the motor systems, how they can improve it. That's what this video is about. So let's go and read some more here. Again, well, we'll get back to this statement, and I'll leave it here. So he said, anyway, he doubled the available output. This is Floyd Sweet again, in this experiment way back in the 80s. He had doubled the available output section from 500 watts to 1,000 watts in 100 watt steps, that is, series of additional impedances, thus increase the negative energy output in fraction. So again, we're going to look at, just like the cells in the battery, we're going to look at adding more and more impedances on the negative energy path, or line propagation. So at 1,000 watt limit, the unit had smoothly lost in steps 90% of its weight on the bench by accurate measurement. And he had said in there that he didn't want to go any farther in view of the possibility of blowing up the magnets, which he had already done. So now, years later, so there's a whole problem he experienced after he did that. Anyway, I'm going to jump over that point. Years later, Sweet also brought up that anti-gravity experiment subject again. We had an interesting discussion. He stated that when he did that weight loss experiment, he was so completely astounded that he could not let it go at that. Finally, after much moping and agonizing, he decided to throw caution to the wind and just try more load. More impedance, therefore more negative energy and more COP gain, and more heaviside negative energy curled component. So he added more impedance, ran the experiment again with the unit tied to the bedpost, and then the darn thing levitated according to him, and lifted until restrained by the end of the cord. And he goes on about modifying it and having it move all the way around and everything. Anyway, since then, over the years, I've continued some work as I could in negative energy. And Bearden and I, a few months ago, filed a most formidable provisional patent application on the use of negative EM energy in electrical circuits, and included some small but real working circuits used and discovered by Bearden. He says, eventually, once the technology is developed, negative energy circuits will power the world cheaply and easily, since longitudinal flow of EM negative energy along a series of ordinary impedances will result in very great convergence of extra negative energy from the vacuum environment into that energy flow. Hence, simply and easy direct amplification of electromagnetic energy, negative energy flow is practical. But you have to get the distinction first, and this is where people fail because they're focusing on the positive rather than the negative. Which, spiritually speaking, is very important to do, but not what we're doing here. Further, to change it into positive energy, just charge a capacitor with it. Alright, so we've got a capacitor. So we could just charge a capacitor with it, with the capacitor leads reversed from normal, and then switch away the capacitor into a normal circuit in the normal connection manner, and the capacitor will now discharge positive, normal EM energy into that circuit to power its loads. So now, it has to be negative energy. It can't be positive. Otherwise, you'll have a problem with your capacitor. And then there's various ways to charge a capacitor in that way. So if you think of this, I'm going to give you a little hint here. If you think of this as a one-wire circuit, forget the return wire here, and just focus. We're going to talk about this a little bit later, more specifically, but think of this as Tesla's one-wire output. And I do demonstrations of this in my meetings where we have no end to the one wire, and we're running a load across the one wire with no end, like the end is open. Or we can run a load, so it's like a capacitive, well, that's something different actually, getting on to something else. So anyway, think of this as a one wire, and think of the Tesla hairpin circuit as an example. So he files this patent, he talks about this, yeah. And he files this patent, provisional patent, which we've looked at years ago. And I got a chance to see a lot of the stuff behind the scenes and work with, more in-house documents and with different inventors behind the scenes when I was involved with these people. And so I have a little bit more understanding than just what's in the literature here by experience working with this stuff. So I'm just sharing a few things that I can and how it relates to this motor here. But remember, he said that what he wrote me, he said the most important thing going on in this planet is what you're doing, because really nobody else is doing anything along those lines. Now I beg to differ with that statement that he made along those lines, because there's obviously many other people, and I think he wanted his team to succeed rather than maybe the competition. So there's obviously a lot of people working on these things, and they're not on the internet about it. So anyway, going back to, in the area of negative resonance absorption of the medium, COP18 is routinely achieved in IR and UV. However, to prevent being called a perpetual motion nuts and attacked and suppressed, those scientists in that field almost never speak of COP or of the actual thermodynamics of the negative resonance absorption phenomena. Instead, they speak only of increase of the reaction across, or the reaction cross section. So, and like words, of course. So he's got CVS Laktakov, however you pronounce the name, stimulated emissions of an ensemble of scattering particles with negative absorption in 1967, pages 261, 265, in ZHETF plasma. And then, of course, Craig F. Bourne, how can a particle absorb more than the light incident on it? American Journal of Physics, April 1983, page 323 to 327. So anyway, he goes on about that to some degree, and then later on he says again, by sharp pulses for sharp energy gradients across very small space intervals, temporarily persisting Dirac sea-hole can be produced. They flow backwards in circuits and produce from their moment of formation negative energy EM fields and potentials. So that is my presentation on that, which we want to again focus now on just some applications, because you see all these things and people don't understand the words and how they relate. And so I've been doing these demonstrations for nearly 14 years now in existing products. And yeah, so anyway, so let's look at what we were talking about. You have a negative transmission line, and normally I have it connected right up to this charging battery, and now we are making this a negative resistor. And so the energy is coming in from the local environment, whatever your theory is. It's not coming from this battery. And in fact, if this battery charges at the rate that this is discharging, then that would have to be so. And it's not in a loop with this battery, it's actually in series. This terminal here is connected to this terminal here. And I'll bring the camera over and we can look at that later on after I run it. So, I'm sorry. Yeah, this one is connected to this one right here. So the charging negative and the input positive are the same terminal. So this battery is in series through this, you know. So these two potentials here. So we can look at the charging batteries, 1248. So if we go over from here to here, we can see 25.2 volts because they are in series with each other. And now depending on the sharpness of the gradient and the purity of the negative energy, we will be able to really maximize output along this line. So think of it kind of as, I say think of it as one wire because, and you notice how thick the wires I have here for a reason. because the smaller the impedance is from the start, right out of this diode here, the smaller the impedance I put first, it will limit all of the subsequent impedances. So a lot of times when you have a bad battery, the first positive cell is worse than the others, so it's going to really affect this kind of charging of a battery. So it's kind of like it's bottlenecking it. So then what we want is, I mean, I could have really thick wires. I got here 6-gauge wire, and if I had really big, huge, short connections, like literally having this connected right to the battery terminal would be ideal. Or really thick copper bar right there across, kind of straight into it. So now instead of that, we're going to, well, right now we're bypassed with this brown wire here, and so it's going into the battery, and then we will open it up and show you the difference. So what's going to happen here is that we have basically around 1-to-1 charging in this situation, where this battery is going to discharge while this battery is going to charge while this is discharging, and then we're going to run our loads and our motor, which is a light up here that's going to be shining down. That's another 100-watt LED modulator. We have 4 over here. The reason why I put 4 in there is because they can blow out if I exceed the 100-watt limit. So what I have is 2 sets of series. So we'll see the, well, what I have is they're about 35 volt LEDs, so I put them in series with each other, 2 of them, and then they have 70 volts together, so that I don't exceed that. And then I parallel that with the second group, and then this is a photo flash 10,000 microfarad capacitor. Microfarad capacitor, I didn't say that right. And this is a photo flash, so it will really take those pulses very well. And it is 300 volts, so it will really absorb that spike. And then there's just a regular bridge rectifier here. That's a 50 amp, 1000 volt one. And that's all there is. There's nothing else here, just connections. And this isn't really quite ideal because this is not meant for the frequency that we're running at. We're running at about, well, at one point we'll run it faster. Then when we load down the motor, we'll run it slower. And that's where it wants to be. It wants to be running at a proper RPM so that it can switch at the frequency it was made for. So now, let me describe, before I run it, what I did. Actually on a motor that's not running at the amperage that this is going to be running at. Running it at about 500, the smaller motor that had the smaller rotor, that had the trigger coil, which was really the more negative energy output on that system. When I ran that with this transformer and some really big ones that were 5,000 watt, I had 13 impedances in series with each other, including the battery at the end of the line. So 16 different inductors, transformers, and what have you. And when I did that, I received 5,000 volts coming back into the input of the motor, and it of course destroyed the transistors, and I had to limit it with, like I said, this capacitance and what have you. So you have to really, to do this, you have to deal with all that kind of stuff. And that's why I didn't show it was in the box for years, for a couple of years, because I didn't want people blowing up their parts. So now that we're using the higher voltage MOSFETs or transistors, we can do that more, but carefully. So it's one thing to do it, it's another thing to control it just the way you want it. So what I was saying earlier about this could be considering as one wire, in that if I put a smaller impedance at the front of the line, it will affect the other ones down the line. Now if this was regular positive current, it wouldn't matter if that small impedance was at the front of the line or the back of the line. You would still have a limitation of current anywhere along the line, according to Kirchhoff's laws, right? And you would have equal amount of energy passing through all of them, and they would all be impeded. They would all be less running with less output. Like, okay, so if we had each one of these, which is what I did, I had loads running off of each one of these, but when I put the smaller inductors first, then these bigger inductors didn't put out. They put out the equivalent of what the little ones were putting out. So they were very limited. But when I put that little inductor on the back of the whole chain, 13 inductors, that's why I got a whole bunch of these to show, then they all lit up like they were supposed to light up, and the little one was at the end of the line before the battery. So it was right off of the terminal, and it lit up like it did at the front. So that shows you exactly that you have a completely different type of energy. Well, not only that, but you have all these loads running. Obviously, it's a different type of energy. So, and sometimes I forget that, right, in what I'm doing. I forget that positive energy does not run the same way as negative. So when we do, for example, this MIC coil at the front end with this input wire, we're dealing with positive energy. It's completely different. So in this case, I put this coil in here, and I put this in series, and I put this load, which is a ferrite rod with a secondary wire here, and I run this load. Then I get limited results, but yeah, I still get a benefit from that. It's an impedance, and it will work that way a little bit too, but it's going to be quite a bit different in the results than when I do the negative impedances, the negative resistance, the negative energy. So, you know, I wanted to try to compare that. Not in this video, we're not going to run that, because I wanted to use some really big wires here and show this. So, if I get everything just right with the right materials, I could keep adding to that if I have the pure negative energy flow. This is what Tom was saying to me. He was saying, if you have series impedances, you can keep multiplying them, because the energy is just the opposite. The flow is not dissipative. And so it's limiting by the weakest link. True. So if you're using clips, and here I'm even using aluminum terminals, which should be copper and what have you, all these different things that will affect the specifics. So as we go down the line, we're powering all these loads. Now in this case, I have some positive energy coming through that dissipates the negative, and I don't have any resonance here either. Like, remember he says the resonance, negative resonance. So you can do positive resonance and negative resonance in this situation here. But so anyway, you're going down the line, you're adding all these, and they will eventually affect each other the way I have it set up here. So as I add another one, the total output will slightly diminish, but not proportionately. It will not be equal. In other words, I'll produce quite a bit more energy in its particular load than the diminishing effect. But we'll see here that the battery will charge less. So for now, for most people who don't believe in this or whatever, they can at least see the kind of the amount of energy that is going into the battery, at least represented in the light. And so we're not going to be going over 60 watts worth of input energy here. And so what kind of energy can we really get out of a motor that's running off of 60 watts, in which is powering this load up here that I'm going to show, and then also this load. But my point isn't really to show those kinds of numbers, it's just more or less to explain what's happening and highlight this, because people have missed this over the years. So I guess we'll just go and do the demonstration now. So what I want to do is, I'm not sure if I can get this amp meter in a position that can be seen. But I'll move it around so that you can see it. Alright, so we're 1248, 1247 on this charging battery, and it should be down to like 11 volts, 11 and a half volts. Should be down to 11 and a half volts so that we can actually create more of a need for charging, because we're limiting the output. Well, actually we're on the end of the line, so it's not as bad, but for the battery's sake, it wants to be charged up, but if it's already charged, then we're limiting that ability to be charged. So in this case, we would be actually putting a load on this battery periodically to discharge it. But if we get this done in resonance, we can get it so that this battery is really not discharging, and neither is this one. It's not charging or discharging. And that's kind of the goal of what we want to do with these motors, so that there's no battery rotation, and then we can just keep adding these series impedances. So let's start this up. So what we have right now is the generator coil is shorted, and the there we go. That's good enough. and then we'll show before and after with the generator coil connected and disconnected and so forth. We can move the hall around a little bit. Oh, the other thing I have is I have just under 1 total farad of capacitance across the circuit input. This is what we've always done on the big motors. So on a kind of final setup that I make, not that I ship out like that to people, but when I make a system for myself, I'll always put the capacitance right there at the circuit. So that's, when I just did that, it brought the voltage down. It was running up a little bit higher than that. So what I want to do is disconnect this other capacitance right across the MOSFET to show the difference after we've done everything else. So let's give it a start. So I have a 200 watt LED illuminating this room up, and so it's not going to show as much until I turn the lights off. Anyway, we have here 2.6 amps. We're running really low because it's shorting out the generator coils. And so we have only 48 volts peak to peak, 58, 60. So we could actually run this MOSFET with those capacitors across there in that way and not exceed the 100 volt maximum. But we want to be able to go to 24, 36, 48 volts on this. So now when we disconnect the short there, now we're lowering. Oh, let's look at the frequency first. So we're at almost 400 hertz. Kind of trying to measure all the different waves, so it's hard to measure it. Let's load it down now. Like I said, let's run the light. So what we have is running this into a bridge rectifier and then 20 microfarad capacitance across the LED. And it's still not very clean. It's still really pulsy up there. But when we did that, we went up here in voltage peak to peak. So we're at maximum of 88 volts and just over that from peak to peak. You can see the waveform. There's quite actually, when we really open up the peak, the waveform is actually 212 volts, 214 peak to peak when I open this up. And right now we're at the level of 10 nanoseconds. So this is a very fast, it's a new MOSFET technology. It's really the fastest ones you can get, and it's high voltage to deal with this. So we shouldn't be really getting this very hot at this point, except for the fact that it is turning on, oscillating quite a bit. So there's these very short, well actually that's the off time, but nevertheless they have a real ringing, and it's all complicated to try and learn all that, figure it all out. But so now what we're going to do, we've been charging this battery 1282. Now it's going to slow down the charging as we run this load. I should have done that first because now so the amperage is at 5 amps and the voltage on this battery is 1224 under voltage drop load. So now we're going to disconnect this jumper wire. And now we're running that. You can hear a real buzzing here in the toroid. So now we've got these running at, they get pretty hot, so they are pretty bright, and they are putting out quite a bit of power. So, you know, about 5 amps here, 5.3 amps running here. And what else? So so now we can see the charging battery has stopped charging as fast. Still charging. It's coming down because it was under charge, and now it's adjusting to a different setting. But we can see that the frequency has gone, or the voltage has gone up now. And I've shown this 3 years ago now in the Seltzer Circuit's Loving Path when it was in the box, and this was in the bigger box. So it's out of the box now. Anyway, whoops. It makes me nervous when something goes thump. So now the unexpanded voltage peak to peak, we were at 48, 58 volts. Now we're at 180 volts. Now if I expand it, maybe see that even more. No, so the initial one is still 220, but this other pulse is even higher. Well, see, you can see it goes way below. Well, yeah, that's about right. Yeah. Anyway, the waveform changes a little bit, but the spike now is much higher because of this negative impedance. So how would this affect the input side? It doesn't make sense. And it actually affects the input draw a little bit too. So 1224 still, and that can slow down because we have excess of power coming in. Now if I check the voltage down here, we could put another capacitor across the battery itself. So I wanted to make it right there. Yeah, it's still showing the same. There's still a voltage drop from the battery. Even with this big long wire, thick wire, you still have a voltage drop on the input. Not important, not part of what we're talking about, but just wanted to check that. So now we've slowed down the discharge rate and the charge rate, and now we're running this load. So as we add more of these, this spike is going to go up. That's why we need the higher voltage effect, because already right now we're exceeding this. And people who try this forget about the maximum 100 volt limitation here. And that's why I kept them in the box, people, because I knew, and I'll say this again, you can damage these and they can still function, but they're not going to give you the goods anymore. And that's what people don't get. And people often, and I believe me, I spend hours talking to people every day on the phone, and that subject comes up more than almost anything. That people have immediately damaged their parts, and then they may even be using those same parts for years and not realize why their results aren't as good as they could be. So now like I said, as I showed in that first video in the selfish circuit series, selfish circuit loving path, which is really a Benitez process, when I added the series of impedances, which inside the box, the black box, was 6 inductors, and somebody sabotaged it a couple of meetings back, and I know who it was. That's why I don't want people touching my things. Please don't touch them at my meetings, because sometimes it's accidental where people touch something, but now I got to open up that box. It's really tightly packed inside there, so something got damaged. So anyway, I had this in series with the black box. This was in its own box, and as I turned on each switch, you could see the voltage rising. And I did the various experiments, putting the LED in the water and stuff like that, without any electrolysis happening. But you could see this voltage go up and up and up. Now I didn't show all the inductors, like all these, the bigger ones that I have. This is only a 1500 watt transformer. So now, the idea again is to get this all balanced out, and I don't have it quite ready with all the numbers yet for a commercial product. But what we'll do is we'll sell modules, but you'll have to be dealing with certain voltage inputs and certain amount of modules for a particular setup. It will have its own, each one will have its own set of numbers that have to be all matched up right, so that we can have the right semiconductor switching and everything's balanced out. So ideally, like I said, we get everything just on the battery standing still. And then we have the generator coils running. So if I had, for example, ideally, I wouldn't have this motor running at all, any loads, like we're doing with the generator coils here. What I would have is I gotta restart this thing. Ideally, we would have this spin at the maximum RPM, but we would have to have the right core material here. You don't want air core because it's too low frequency, but you don't want a regular transformer because that's made for 60 hertz. So this is going to be running at, we could get this thing up to, if I run this with the double spacer, with the double stack system, I could get up to 10,000 RPM really easily on that. And then when we short out the generator coils, and this is spinning really fast, and we could probably turn it down a little bit too, so that the on time is really short. We're going to really get that negative going. Then you'll see a much greater output here once we get the right cores to run this. So that's why when I short this out, this is not going to run at all, not because so much of the amperage, but because we're going really out of the frequency that this needs to run at. So now, of course, we are running at 2.5 amps. So this is really spinning. If I add more capacitance to this, you'll see another effect. Yeah, see, that doesn't work, sorry. Actually, on this side, you'll see that more when I load this down. So let's let's run this with another capacitor across the AC side. Because that one is across. Actually, I think that's across the AC side. So we're going to do the same thing. So let's look at the amperage. So we're at 5 amps. So it's slowing down the motor, which is drawing more current, but we have more total output, both in that light and that one a little bit. So 12. So it's slowly discharging this battery, but not as fast as if we didn't have that on there. And this is just basically coming up to a very slow charging rate. So if we add more, we're going to put more energy into this. Now what we want to do is shut this off. So what we're going to do is run this again. Without this capacitor, which is kind of dangerous. In the sense that that voltage could get up there. So I want to look at the voltage first with everything less connected here, or I'm going to just short out this with a jumper wire. So now we are set. We're shorted both of these loads. So I want to look at the spike to see if it goes too high, and I also want to measure the temperature. I do have a heat sink on here because I'm still testing this particular MOSFET. Still getting pretty warm, that one, because of so many oscillations. Oh, I gotta hook up. I don't want to be hooking this up while it's running. So I can connect right to. Alright, let's try that again. So without that cap, we're still at those same voltages. We've got some really high spikes though. So I have to turn it to the 100 volt level. We're at 420 volts without that capacitor. So really high spike there. So you can see why we wouldn't want to run that. Alright, so now let's disconnect this to slow it down. Now the voltage is way high, and something just happened that it got damaged. I heard something and it exceeded the maximum of the MOSFET there. So I just damaged it. That spike is gone. You could see that it was there, and now it's gone. So that's exactly what I didn't want to happen, because I only have one of those FETs test, and I wasn't finished testing it. But anyway, I exceeded that. That was the first time that I ran that without that capacitor. So I could actually hear something go inside or over here. And it's interesting that it's running colder now. But what we'll do, so we can see now that the voltage peak to peak is nowhere near what it just was. Now we're at 230. So what will happen when I run this is it's still going to run, but we're not getting that spike like we just had before. So that's very interesting. $230 volts, 200, yeah. So there you have it. Anyway, that's why I did that at the end, not at the beginning. But if the camera can see that good enough, maybe it doesn't. So what I'll do is I'll bring the camera around right now. Now you can see the voltage is reasonably gone up here. But from this point I'll bring the camera around and you can see everything. Alright, so starting with the load up here, you can see we have a capacitor, a bridge. This was where the original LED drivers were. So if I run this shorted, now we can look at it more without the light. So you can see the bridge wires coming in there and just going there. So now we can see the spikes that I was mentioning. Relatively low compared to what it was. Now we'll expand it here. Oops. Then you can see only 230 volts peak to peak. You can see it going negative there anyway. And then you can see it rising up. And then what I'll do is I'll short it. Oh. Trying to do two things at once here. So you can see the voltage went down. I shorted out light, and there it comes back in. The waveform changes. Alright, so now let's look at some things here. So that was a little 0.1 microfarad capacitor that was saving this MOSFET. And these are the 5 farad capacitors in series for 0.83 farad, I guess, or something like that. And they are right across the input. So you can see the wire connected right here. And then the other one comes in, goes to the negative, oops, underneath the board there. So like I said, I put a heat sink on this because it is getting up there. So I can't sell this right now until we deal with all that. I'll probably do a different FET than this one. Okay, so there's my ammeter. And now let's look around here. I'm just doing funny business here. So then here's the light. Of course you can see that real clear. It's interesting because this is very, very bright, but it's auto adjusting. But it's better to spread out your LEDs like this so that, oh yeah, so here's the capacitor that I have here. It's kind of a one-shot deal. Can't get any more of these. I'm going to go to the company and try and find those because that's a special photo flash one. So we're going to lift this up now and look underneath here and see that the wire is just coming out of there and going in. So you can see this is not being used, this wire right here. So I was just jumping across these two terminals here. These are just my secondary wires on my transformer. So what we have is input battery, or sorry, charging battery. Comes there, goes through, red wire goes back to blue wire. And there's going back to the primary positive. And see, really that's where you're supposed to put it, right at the input terminal. So I think I'm going to do that from now on all the assembled kits. That's where it's supposed to be. And you can look at it closely here. So let's look at the amperage again. About 5 amps, kind of with this meter, depending where you put it, it'll change a little bit. And then we can look at the voltage again. Of the batteries. This one's slightly going down. And that was slightly going up. So we want to actually stop that from happening with enough series impedances, like I said. So let's stop it for a minute, or for good here. And look at, you can see the connection that I had here. There, and then it just goes up. So this is just an extra 10 microfarad capacitor that lowered the frequency down, and it's the same kind of thing. Oh, you can see that this is slightly discharging still. We can see the capacitance voltage, capacitor voltage there. It's still 24 volts. So obviously, if these were in parallel, they would still be on, but they have a slight, so they're at 12 volts right now, and they still have the ability to come out of it. So you'll find that these aren't all perfectly matched, even though I have the same length wires, 2 of each, coming out to each side. Some will come on better than others, and if I've pulsed them too hard without like a suitable capacitor there, then they will get damaged, if they have too many spikes across them. So, but anyway, you could charge a battery with that instead, but the lights are very useful as well. And so this is, again, the basic system, and it allows for what I call negative energy pumping, negative energy engineering, which is something that few people even know is possible. And so we can run any kind of load on here through these means of either directly to a battery, or we can charge multiple batteries. So this is, again, the basic impedances that can convert to useful energy, become negative resistors and negative impedances, to be specific, and then we can convert that. In fact, this is converting the energy output, kind of like the capacitor itself. Now, this is not isolated. I could have used these other 2 wires here, or the higher voltage wires. I could have used those and had isolation. But here I'm just running, you can see directly off of that. So really, it's really across the bridge too. So really, that's another whole thing when we run this isolated. But that's kind of dangerous too, because we're trying to avoid what would happen there with not having enough capacitance there, in that if we have too much energy going back, it will blow things out. And it's one of the reasons why I also put the capacitors across the input, which is not necessarily ideal for the charging of the battery back here, because what's happening is that energy that's coming back into the input is getting absorbed into those capacitors, and then they feed the positive energy back in. So in that case, we're not going to be charging this battery up as much, or keeping it from discharging as much when we do that. So these are kinds of options that I've had to explain in this video, so people will understand, some of the differences that you can do. And again, we have negative energy coming through this line here. Like I said, the heavy side current is at this. If you have your wind sail, the energy is flowing outside here, and so these are like the battery plates are coming back here, and in that they're in this direction, and so the flow is happening external to the conductors around, and the pointing is only on the surface. Very little of the energy is actually intercepted, according to the theory. So we have this negative energy coming out. Like I said, if we put limiting impedances, it will limit from that point on. And if we put that on this side, or right here, the limiting ones, after, they will still run. They will be quite different when you have the real negative energy coming out. But you have a mixture of some positive and negative in this whole thing. So that's kind of a dampening process. But if you have too much, like I said, you've got too much energy coming back into it. So you have to kind of do something that's practical. Now, what Bearden talks about, charging a capacitor backwards and then outputting the positive energy, is what we do when we have the negative energy. We charge up a capacitor and then we discharge it into the battery, and then it converts the negative into positive in that way with the SCR pulsar. And so if we want to do the battery rotation and we want positively charged battery, that's what we do when we have the real negative energy circuit with the trigger coil. And this can be that way too with the high-speed switching, the sharp gradient with the gate driver, which is right there in the center. So yeah, but we can do also it more directly without the SCR by thinking of this as a one-wire charging of a capacitor. And if we think the Tesla hairpin circuit, which I've talked about, so I should really pull that out in this book here. Let me look for it briefly here. I think I have it in another section of the book. So this is kind of like the Tesla hairpin circuit in a way where you have the isolation. Yeah, so this is really the same sort of thing with the motor. So you have here the output inductor. You have the capacitors on either side. So there's no real electrical connection from that side to this side. And so this is just like where he was running the bulb shorted. But there is somewhere a picture of that somewhere here. Yeah, right here. So you have all these one-wire things in this, which I talk about in this book. And so here is the short across the top. Again, you have the two capacitors. So this is shunted right up here, but these lights are parallel to the short. Now that's a high frequency system to do that. But that's what we're talking about when, if we're doing the negative energy, and we just imagine the one side, we could also run the bulbs across that way, which is what he's showing right here, for example. One wire output in different ways. So this can be with positive or negative energy. You can charge a capacitor positively and you can charge it negatively. It's hard to understand, but and then the back EMF of a a negatively charged input becomes positive on the output. So it's just the reverse. So I think that covers everything I wanted to say. Yeah, so hopefully this helps some people. And like I said, we'll do is we'll make some options here. This is really a lot bigger than it needs to be. But like I said, the bigger you do, the more output you can get. But it's pretty expensive for this size of the motor. This is probably more for our bigger setup. The bigger 4-pole dual pole system. It's just like running this off of and trying to charge up, 2,000 amp hour batteries. It's not really a wise use of those size batteries. You can get a much higher COP with that, but you're not getting over time as much energy really than for the cost of those batteries than you would be using a bigger system with less COP. So let's see. Yeah, so we'll make some of these things available to run with this machine, and then we'll. Some of the people are waiting on some of their orders because I am going to provide a new MOSFET for everybody that will be able to do this more, and you'll get better results from it. So, yeah, that's all I want to say for now. But really, you can, once you do this all, in the end, you can make this a prime mover, and if the batteries stay the same, then you can end up adding more and more loads here, and then multiplying the energy out again and again, and we could easily convert from positive or negative outputs. So it's the ultimate. So anyway, thanks for watching.